Okay, and now we are going to talk about brightness, contrast, and gamma. So we use the lookup tables to change what we see in the image. So the way the computer is displaying the image. So it's just a tool to help us. We can put artificial colors, as I said, but also change the brightness and contrast, and that changes what is displayed, but not the data. So in the Nikon software, it looks like this, but in your software, you will definitely find a place where you can change the lookup tables, and that can be in a different way than this. What we see here in the Nikon software is that we can change this manually. We also have ways to do it automatically. And again, it's the same thing in all software. When you do it automatically, if you press one of these buttons that do the auto contrast or something like this, what it does is it displays as black what is the darkest value in your image. So if the darkest pixel in this blue image is 38, then the computer is going to set this to black. And then it's going to go to find the brightest pixel and set this as black. And then it will display all the, in this case, 4096 values within these two values. And so it sort of stretches the display in such a way that you can see both the darkest and the brightest in the image. So this is what happens when you do it automatically. And then you can also, of course, move these little triangles by yourself if you want, so that you could move this a little bit closer to here and basically make the image look darker, or you can move this a little bit closer to here and make the image look brighter. Okay. And you can see in here that we have the maximum possible intensity is here. But in this image, the maximum intensity in the image is 1000. So there's a difference between the bit depth maximum and the image maximum, right? The bit depth is just what is possible in the image. And these are the real data that we have in our image. So what you can see in this image is that in this blue image, most of the pixels have an intensity that is around 150 or 175 or something like this. And then we have less and less pixels. And here we have anyway the maximum. So all these pixels that are here, there are very few pixels at these intensities, but all the brightest pixels, they're actually part of the noise. Okay. And in here, it's the same thing. We have a lot of pixels here. Right? It's very few at each intensity. It's probably one or two at each intensity, but this is part of the noise. It's the same in all images. And then when we have an image where we have a lot of black in the image, so if your sample is very sparse in the image and most of the image is black, then you will see that the peak of intensity shifted to the left side. And that is because most of the pixels in the image are black. And that's normal. If your field of view is like this, and then you have sparse cells, for example, it's normal that the peak is shifted towards the left. But what we want is when we set the intensity in correct way, the maximum in the image should be very close to the maximum bit depth without reaching it, just below. Okay, same thing for the other side. We should be very close to zero, but just above. Right, so this is the way we can change the brightness and contrast. If we sometimes it's not easy. If we push the brightness and contrast, we can see the dim details, and we can also see when the sample is out of focus. That can be very useful if you focus on your sample with, as I'm showing you during your workshop, your student imaging challenge workshop. You focus on your sample with the eyepiece and transmitted light. Then when you go to the microscope and you grab an image in fluorescence, the image is likely to be a little bit under focus, not in the correct focus, because the eyepiece is going to be set for your eyes, or maybe not correct for your eyes, and it's a different focal plane compared to the to what the microscope image is. So you will have to refocus very often, and this is very useful to push the brightness and contrast to see things that are a little bit out of focus, find them, and then you can refocus. Unfortunately, these tools are extremely useful for you to see lots of dim things and whatever. So use the lookup tables to push the brightness and contrast, but it can trick you into thinking that your parameters are correct, even though the image is, for example, very dim. Okay, so it is important that you reset the brightness and contrast, and you look at the histogram to understand where your if your parameters are correct or not. So when adjusting the imaging parameters, reset the brightness and contrast, and do not believe your eyes. If you use a 16-bit image, it is likely that you will have, because there's so many gray levels, that you will have to push the brightness and contrast to see anything at all, but then check the histogram, okay? So do this thing where you use the lookup tables when you need, you push the brightness and contrast when you need, but learn how to reset it to set your parameters. So where do we get the brightness and contrast? A lookup table in Fiji. You have already used this under image brightness contrast adjust, image adjust brightness contrast. We can get that, and this is what it looks like, and you can change the minimum and the maximum, and you also have an auto button. And unfortunately, you have this button called apply that you should not use, because if you click apply, it actually modifies the data in your image. And so you can always work on a copy of the original to make sure you do not modify the image. And of course, if you change the brightness and contrast, and you publish these images like this, then you need to mention in the material method. And it can be just, you don't have to mention it for each image or whatever. You can be just, okay, the imaging parameters have been adjusted to have no saturation, no underexposure, and then the brightness and contrast has been pushed in the images to show what we need to show. So it can be a very simple, a general statement for all the images. So now there is something else called the gamma. So here we have the minimum and maximum, and here we have the gamma. So in different software, it's going to be displayed in a different way, but basically you're going to see it somewhere at the place where you can change the brightness and contrast. Very often it is displayed like this, as a line with a little ball. Okay, and so what do we have in here? So this is the little ball. You take the ball and you move it around, and you will see what happens. So this is available in all microscopy software. And here is an image. There is no lookup table adjustments, so we are actually displaying the full bit depth of the image. And what we can see is that we have some dim areas and some bright areas, and we would like to see details in both of them. If we push the brightness, great, now we can see details in the dim areas, but unfortunately, many places look saturated, so it looks white like this. And this is then you mean you lose all the details, cannot see the details in these bright cells either. So instead, what you can do is not push the brightness and contrast. So I've reset to the whole range, but you change the gamma. And so this curve is a little bit bent. It's a bit difficult to see, but this one is bent, whereas this one is straight. When we have gamma 1, then the line is straight. And when we have a gamma that is above or below, then the curve is bent upwards or downwards. And what you can see in here is that I now see details in both the bright and the dim areas. So this is very useful, the gamma. But the brightness and contrast affects all the pixels equally. So this is a linear adjustment, the brightness and contrast. Whereas the gamma, when you change the gamma, only the bright pixels or only the dim pixels will be affected. So the bright and dim pixels are not affected in the same way. So it is non-linear, okay? So the lookup tables are adjusted only for the dim pixels, only for the bright pixels. And so in this image, we have adjusted to push, let's say, the dim pixels and to leave this unchanged. Therefore, you will never do any intensity. You cannot judge this image with your eyes or with image analysis if this gamma has been, the data has changed. The intensities here are wrong, okay? It's just a way to display so that people can see details, but the intensities are modified and wrong. So the brightness and contrast and the gamma adjustment must always be reported in articles. So when the image that I showed you before that was underexposed, when we remove the lookup table showing us the underexposure, this is what the image looks like. We may be tricked into thinking it's fine, but when we actually, so this is the same image but acquired without underexposure. And when I lower the gamma to see the dim details, so I apply a 0.5 gamma, I can see the difference between the images. So in this image, there is no details at all in the edges. And, I've lost all the phylopodia of the cells in this image that was underexposed. But now with the gamma, I am able to display both the cells and the very dim areas in the sample. So now with the underexposure, I've lost all the fine intensity details at the edges of the cells. So in Fiji, you can go to process math gamma, and then you get something like this with a little slider. You can click on the preview button to see what is going on and say, okay. So in Fiji, remember to always work on the copy of the original image so you do not accidentally change the data. So in our image that we had at the beginning that was looking really nasty and where we could only see the green background when we adjusted the parameters to have no saturation and no underexposure. If now we are adjusting the gamma, this is what we can get. So you can see that there's a lot of things that can be done after acquisition to fix, let's say, the look of an image. What is important is when you acquire it that you have all the data. And you can see here that I have changed the gamma in such a way that the dim pixels in here, all this background in the sample has been is gone. And same thing in here in the red channel. So we have a lot less background in the sample. And again, all this is valid. All this, there's no cheating in there. You can do all this stuff. You just mention it in the material method. And for this image, for example, I would write under the image what the gamma in each channel is. So the bit depth determines the number of possible intensities or gray levels in the image. It's not the maximum intensity in the image, okay? You choose the bit depth to match the need of your experiment. If you want a high speed, you go for a low bit depth. If you have very low and very high intensities, you need to have a high bit depth. So if you have a tendency to saturate your sample, go for a higher bit depth. And always turn on the saturation and underexposure lookup tables. And you can change the lookup tables with the color, brightness, contrast, gamma. It doesn't change the data. It only changes the way the images are displayed on the computer. Look at the histogram to choose your imaging parameters. Try to have the brightest pixel in the image close to the maximum, but not at the maximum. And the dimmest pixel in the image close to the minimum, but not at the minimum. Do not believe your eyes. And try to get this histogram filled as much as possible without any saturation and underexposure. So change the bit depth from 16-bit to 8-bit to be able to open images on the non-scientific software. But if you do what we have done so far, if you save a copy of the image as JPEG, this will automatically reduce the image to 8 bits. So then you don't have to change it before. You just do whatever, display your image the way you want, save a copy as JPEG, and that you can immediately put in your non-scientific software like PowerPoint, for example. Always mention in your paper any modification that you perform on the original image. And I'm just trying to see if I have I just added this. I might do this after lunch anyway. So let me see how I'm doing now. 10:30. Oh, I'm doing great. Amazing. Okay, so we're actually very early. So I think that, yeah, we're very, very early. It's good. Uh, I think that what we're going to do is that we're going to take a nice little break, maybe